Hello everyone. In today's lecture, we are going to discuss about the memory system of ARM Cortex-M processor. So this is the basic memory structure of ARM Cortex-M0 processor. So if we see here, we have the flash memory, we have the SRAM, we have external memory interfaces, then we have the external SRAM, then external LCD SD cards, and also we require timers, UART and GPIOs along with this, and it's been connected to the processor through the AHP bus. So here we have the memories and here we have the processor. AHP light bus is the one which communicates between these two. So this is how the memory is being connected to the system. And let us see what are all the registers available, what is the memory system, how the memory mapping works here and all these things. This is the register bank. Here we have the normal register as well as the special registers. And coming into the memory overview, if you see the memory overview, see here we have the memory from 0 to uh, F, that is S. So memory map here, the this is a memory mapped system, and this memory mapping, as if you see the whole memory, it has been splitted into it's been partitioned, and for every code or for every activity, for every device, separate memory locations are being given. If any peripherals wants to access this, then only through those things can be stored only in this area, right? And this is the internal private peripheral bus, and if you see here, this has in the this last location is reserved, then this location is data wash point, then here we have the break point, then here this is another reserved location, then we have the system control space. System control space extends from this address to this address, and here we have the roam lookup table. And see, if you see the system control space, then the system control this in between these two addresses we have all these controllers. One is system tick timer, NVIC controllers, debug controllers, and everything. So this is how the memory looks, and memory is mapped here. And this is a part of that memory what was being used. And if you see this memory here, if you see here, these all these zeros to all these f's all together, the space is 4 GB, right? So for memory space for an ARM Cortex M0 is 4 GB. And if you see the code region, now let us look into every region separately. So this is the code region, then we'll be looking into SRAM region. So if you see the code region, the size is 512 MB, and out of these 4 MB, almost all the regions are splitted into 512 MBs. Not all, few, most of them, and it is used to store the program code. It contains the external exception vector table at address, that is all zeros, 8 zeros. And then we have the SRAM region, which is located in the next 512 MB of the memory. It is used to store data as well as stack. It normally used to store program codes. For example, suppose if you want to copy a program code from the slow external memory to a SRAM, then we can do it and then execute it, right? So that the speed increases. Then we have the peripheral region. Its size is also 512 MB, and it is primarily used for peripherals and also used for data storage. Program execution is not allowed in peripheral region. The peripherals connected to this memory region can either AHB light peripheral bus or APB peripheral buses. Okay. If it is APB, then it is connected to the bus bridge, through the bus bridge. If it is AHB, then it will be connected to the master, through the master slave bus. Then we have the RAM region. If you see the RAM region, it is again 512 MB. 512 MB. It has two sets of RAM region. So each 512 MB, and totally 1 GB space, right? So 1 GB is equal to 1020. Both 512 MB memory blocks are primarily used to store data, and in almost all the cases, the RAM region can be used as 1 GB as a continuous memory space. It can also be used to store program codes. Next is we have the device region, and the device region, it again consists of two 512 MB memory. So altogether for device region, 1 GB space has been given. It is used for peripherals and for IO spaces. It does not allow program execution. It can be used for general data storage. It is also divided into two halves as like a RAM with different memory attributes. Then this is the internal private peripheral bus. So we have discussed about the expanded version of this also. Internal private peripheral bus is allocated for peripherals inside the processor such as interrupt controller, vector interrupt controller, and debugging components. Its space is 1 MB again. It is a special memory which is used for system control space. It contains interrupt control register, system control register, debug control registers, etc. Then certain reserved spaces are also there. Around 512 MB reserved space was being given when microcontrollers used by other persons for different applications or usages, then they can use those reserved spaces for their applications. Thank you.